Okay, this question's about a student investigating how resistance depends on the length of a wire. And then it's got a photograph here showing the setup that the student would have put together in order to investigate this. And so let's have a look and see what they've got. They've got an ammeter. And so as soon as I see ammeter, I think, right, that measures the current. And I'm going to put that down there because that's going to help me later. Voltmeter measures the voltage or potential difference. We've got the cells here that are going to push those electrons around the circuit, make that current flow. And then we've got this length of wire here and it's connected to a ruler. So I'm going to annotate that and put ruler down there because that might be important later on in the question. Then it says to draw a circuit diagram to show how the components in this photograph are connected. So I can see here that out of the cells we've got a wire that's connected to the ammeter, and then that's connected to the wire attached to the ruler, and then it's going to be connected back by this crocodile clip here, and then it's going to go back to the cell. Now that's our first branch of the circuit, but you'll notice we've got this additional parallel branch here where the voltmeter is connected. But that doesn't come as any surprise to me because I know that ammeters are connected in series and voltmeters are connected in parallel. So let's draw out this circuit. I've got 3 cells here, so that's the first thing I'm going to draw, connect them together. I'm then going to draw the ammeter in series, and then I'm going to draw my length of wire, that's the bit connected to the ruler, and then I'm going to connect it all back up together. So that's my first series branch, and then I'm going to connect up the voltmeter. So it doesn't matter where along this line I connect it, as long as it is in parallel with the rest of the circuit. And those are the first 3 marks to this question. Done. Now the rest of the question continues like this. It says to complete the table by naming the key variables in this investigation. So the investigation was about finding out how the resistance changed with the length. So the thing that the student was changing was the length of the wire. And the variable that was changing because of that was the resistance. Now, the next part of the question asks me to describe the methods that the student would use for this investigation. There's 5 marks available here, so we've got to have a bit of a think about where we're going to get these marks from. Now, I think it's really important that we actually state how we're using the equipment. So we had a voltmeter and we had an ammeter and we annotated what they're for. And marks are going to be available for actually showing that you understand that. So we're going to use the voltmeter to measure the voltage or potential difference across the wire. We're going to use the ammeter to measure the current. Through the wire. And now I've got to think, well, why are we measuring current and voltage? And that's because they're related to resistance. And the examiner is expecting you to know this relationship. And that is that the resistance is equal to the voltage or the potential difference divided by the current. And so, by measuring the voltage and the current, we are able to determine or calculate the resistance. But that's not quite enough, because so far, we're going to measure the current and the voltage, and that's going to give us one reading. But we haven't even talked about length, so we've got to talk about the length as well. So we're going to take these measurements for a range of different lengths. So we're going to take these measurements over a range of lengths in 5 centimetre intervals. And there we've got another little experimental detail there, because we're talking about intervals and how we're going to change the length of the wire by connecting the crocodile clips at different points along the wire in 5 centimetre intervals. And there we have it, I think. We've got enough things to say there, except for we can say one more thing, and that is using the ruler. And that's actually using the ruler to make sure that those intervals are 5 centimetres. Lots of almost obvious things here get the marks, but you know, if you're not familiar with the experiment, this is going to take up a lot of your time in the exam. So you've got to be familiar with your experiments. The next part is the table shows the student's measurements, and we've got length of wire, voltage, current, and the resistance of the wire. And I'm noticing we've got a blank here, so maybe we're going to be asked to calculate that later. This part here says state the equation linking voltage, current, and resistance. You know, we've already mentioned it here, but this is the way I always remember it. Voltage equals current times resistance. Then it says to complete the table by calculating the missing value of the resistance. So we need to rearrange the equation. We're going to have R equals V over I. So V is 4.5. Dividing that by 0.7. We put that into our calculator and we're going to get the answer of 6.4. Now it's asking us to use the results from the table to plot a graph of resistance on the y-axis. So I'm going to put that there now, so I don't forget, against length of wire on the x-axis. So I've labelled my axis, but I haven't put in my units. So I'm going to put in my unit of ohms and my length in centimetres. Now I think it's really important that when you're presented with a grid like this, that you use the edge of the grid, because often they make the grid a useful size for you to plot your graph. So you would use a ruler, but I'm going to do this quickly. I'm going to put on my axes, and now I need to make my scale. So we can start from 0 for this experiment, and now let's put in the length. So let's see if this is going to count up. I need to get to 100, so will this work? 20, 40, 60, 80, 100. Yeah, more than enough space. So we've got 20 there, we've got 40 here, we've got 60, we've got 80, and we've got 100. And then we've got to do the same for the resistance. So it's going from 1.3 to 6.4. So again, I can start at 0, and I've got to get to maybe 7 or 6.5 perhaps. And let's see how we're going to get there. So maybe if I did 1, 2, 3, 4, 5, 6, oh yeah, and a half, that's going to be enough. So that's 1.0, that's 2.0, that's 3.0, that's 4.0, 5.0, 6.0, and then that's going to be our 6.5. So now let's plot the points. So we've got length of wire. The first one is 20, and that's 1.3, so that's right there. 40 is 2.5, that's just there. 60 is 3.8, that's just there. 80 is 5.0, that's right there. And then 100 is 6.4, the one that we calculated, and that's going to be right there. And then, of course, whenever you draw a graph, you always put a line of best fit, and we can see we've got a nice straight line needs to be drawn here. Again, you would use a ruler, but I'm working freehand because I'm working in felt tip rather than a pencil. So, perfect graph, I'm going to get those 5 marks for sure. It says to write a conclusion for the investigation. So we could say that as the length increases, so does resistance. And then we're asked to explain how it supports this conclusion. Well, as the length goes up, the resistance also goes up. And it's as simple as that. The gradient is straight, so the variables are directly proportional. And that's a really useful term to know, because directly proportional comes up lots and lots in lots of different physics questions. Whenever you've got a straight line connecting two variables, it's directly proportional. So as one goes up, the other goes up by the same amount. And there we have it, 19 marks.